hardware resources are very optimally utilized. Okay, so that's what we call as our HPC solution, or the cloud solution. Now let's look at how the software trends are. What's happening these days. People talk about process efficiency. Gone are those days when somebody would sit and mesh through the day and come back the next day again, continue doing the mesh. People do not want to do that anymore. They want something faster, something better, something to cut out their mundane activities. So we work a lot with the automotive companies to automate some of their design processes. Okay, something that is very mundane can be automated. Okay, we work with them, and we have also seen that product development is quite iterative. You start with a concept design, then you go to the design CAD, then you go to simulation or the virtual testing, and if something goes wrong, you come back to your concept design, rework the whole way through. So that's still quite iterative. Certainly much lesser than what it used to take. Earlier car development would take something like 7 to 8 years. These days it's taking something like 24 months to develop. But can we reduce it further is the question that you're trying to answer. And also it's an era of apps. We don't want to sit and do the meshing, use complicated commands to do a simulation. Okay, we want everything to be pretty easy to use. So, and hence the new generation tools are appearing. What is that we guys are doing about it? So let me give you a small short video on what is that we guys are doing. Okay, let's start with this simple thing. You take a block and you apply the loads and constraints. You know that what should be the shape, what should be the right shape or the form factor. It's easy to understand the form factor. Okay, and you do the same thing in the software. Yeah, you get exactly the same thing. You are trying to build a bridge. The loads and the constraints, and that's pretty easy to understand. Whereas if your geometry gets more complicated, okay, then it's not pretty easy to intuitively understand how it should look like. Okay, here is a tool which is pretty unique in nature, which gives you a design. So you just start with a block of material, you apply the different loads that are going to come under operating conditions, and all the supports, you get a design made or design suggestion by the software. Okay, and let me reiterate again, this is pretty unique tool in the industry, and this is sort of helping designers to come up with the concept design early at the design phase. So instead of coming up with the concept design, which you thought about it the previous night, and then you start sketching, and then going out to the designer when he does some calculation, he throws back saying that this is not going to work. Here is a situation, here is a tool which allows you to come up with a concept design that is going to work because it has mathematical foundation to it. Okay, and we are working quite a bit on the UI, the user experience. So user experience is taking predominance now. People want to have intuitive tools, very, very interactive, very, very intuitive to use kind of tools. They do not want to spend too much of time in learning the software, in mastering the software. And then we are sort of bringing down the number of commands, the number of clicks that are required to build a model, okay, or to build a finite element model. Okay, look at this, just a few commands or just a few icons out there. You just click, and a few clicks, your simulation is done. Okay, this is a forming simulation or an extrusion simulation, for example. Okay, again, it has got not many. The look and feel are the same. The set of icons, there might be a little bit of difference here and there, but mostly they are the same. Here is another tool which is for casting, simulating your casting process. So now, what is that we are trying to come at? We saw Nismar's presentation in the morning on how MA is trying to help the local industry to get into R&D. What are the steps that they have taken? So one of the steps, as Nizmar has mentioned, is they have the full suite of HyperWorks tools from Altair, and also full suite from Dassault. So with that in mind, you can actually exploit this facility to start from concept design all the way till your manufacturing simulation. You can use this facility for all your work out here. I just tried to put down, what are the things that you can use, that you'll be able to use in different stages or different phases of your product development. In the concept stage, when you start with the system design, you have the system design tools called ST, Compose, Activate, and Embed out here. And you can also use the solid thinking, inspire, and evolve tools for coming up with the concepts. And then you have the design tools, which are SolidWorks and CATIA out here. And the design validation tools, HyperWorks suite of tools that you just saw, can be used for simple calculations, simple validation, all the way to the crash and impact kind of simulation. Prototype, in the prototype part, to build the prototype, solid thinking, inspire, evolve kind of tools will be able to write out STL files which can be prototyped directly without having to go through an intermediary step. And when you do the testing, there are tools to suck the raw data, post-process the data, and then make sense out of the data. And these are the tools that are there for doing that. And for manufacturing simulation, again, you have certain tools, which can help you in understanding whether your part is manufacturable or not. If not, then what kind of correction you need to make it manufacturable. And then obviously for simulating the NC codes and so on. So I just wanted to put the same thing, in the context of the seat example that we just saw in the beginning. When it comes to the concept design, you can use this set of tools that you see here. And for field of view studies and for part modeling, assembly modeling, you have the other set of tools out there for design validation, optimization, motion studies. Again, you have the HyperWorks suite of tools for doing the ergonomics, for doing safety regulation, be it the virtual tests. So you have all the tools out here in MI. Okay, and MI has also the compute facility, the hardware to carry out compute-intensive jobs. Okay. So this is just to just to give you an idea about how additive manufacturing, Internet of Things, and autonomous vehicles. We are doing a lot of research for our customers, in the automotive segment on the Internet of Things. We are doing a lot of work on the autonomous vehicle area for our customers. Not only bionic structures and optimization-driven design. Just to give you an idea of where the world is trending towards, at least in the automotive segment. So let me play this video. Okay. So what you see here is the future. It's not like 20 years from now, it's happening now. Okay, all the user trials are happening now. It won't be long, could be a couple of years, when you start seeing all those kind of, autonomous vehicles flying on the roads. Now that we have seen, how, what is happening globally with the automotive segment, I'm sure you might be interested to understand what is in it for us, locally. What is it that we guys can do here, sitting in Malaysia? So this is a plan that MII has come up with. They came up with this in 2014, NAP, the National Automotive Policy, to move the automotive companies, the automotive supplier organizations in Malaysia up the value chain. And these are the few areas that they have called out. One is creation of design and development facilities, having the right software, hardware, and test facilities, the right compute infrastructure, and also training and development of more automotive professionals. So we have already started, along with our partners ORS, setting up and training some of the engineers out here. And we are going to continue to do that. We are going to work on the knowledge transfer. So these are some of the targets that MII has set up, how they would like to see by 2020 the landscape of the Malaysian automotive industry. Okay, they have a pretty big task of moving so many companies, 180 companies, from level 4 to level 5, where they become tier 1 suppliers to the automotive OEMs. So the additional thing that has added on to help this whole sector is the TPPA, the Trans-Pacific Partnership Agreement. So how this is going to help? This is certainly going to help the automotive suppliers more so to openly and freely sell their products with all the countries under this agreement. Okay, so Canada and the US have already indicated that the interest for technical cooperation and collaboration and capacity building with companies in Malaysia is pretty high with them. So we are an American company. Part of this, we are trying to see what more we can do under the TPPA to bring up the local companies to graduate from whatever they are to get into R&D, to develop some of the technologies that are required in the near future. The reason why I put up those videos are to show where the automotive segment is trending or moving towards, and obviously we need to gear up. In order to be in the game, we need to gear up to supply components for those kind of vehicles. Okay, so what we did, so NAP, there are 4 pillars, and we Altair, we use that as a partnership framework for our partnership with MII. And MII has been extremely supportive in the whole endeavor to bring up the technology content of the Malaysian companies. Okay, so we do organize what we call as the Altair Technology Conference. This is an annual event, and MII has been participating in that for the past 4 years now. Okay, in some way or the other, they've been participating either in the round table or as keynote speech, or in some form or the other, they've been participating with us, supporting us. So this whole idea is to see how we can work together, how we can help the local companies to grow up the value chain. Okay, so just wanted to give you an example of a company which supplies subsystems. We were engaged with them. The whole idea was to move them up the value chain. They were supplying only components to tier 1 suppliers, and they had a dream to become tier 1 supplier by themselves. They wanted to supply different aggregates, suspension systems or seats or wiper mechanisms to whatever it is. So we started working with them. The idea was to move them from build to print, which is manufacturing only kind of a company, to build to specification, where they can design based on the specification and then manufacture and provide the whole aggregate. We started working with them on the design concepts, improving their skills by training and retraining, and redesigning the whole design process. So these are some of the examples where they could supply to a Chinese OEM, where the Chinese OEM gave just a specification, and from that specification, we worked with them to arrive at the technical details, and then went through the whole motion of design and development of the seats, including the physical testing, okay, and then the correlation, and then obviously there big part was optimization. We tried to reduce weight wherever possible. This is just one example where we reduced 30% of mass, but there have been a lot of other components where we could effectively reduce the weight. And guess what? Finally, this company was able to deliver the seat to the Chinese OEM, okay, which is pretty good. And that was more because of the collaboration that we had in place, okay. And mind you, this was a case where this company was saying no to an offer that was made by the Chinese OEM because they felt that they do not have the required expertise to develop something from scratch and deliver it, okay. And since we told them that we will be at the back end doing all the technology work for them, they agreed, and then they were able to successfully deliver the product. Here is a case, where again working with MITI on the long-term plan. So we are trying to set up what is called as the ECOE, or the Center of Excellence. We are in discussion with MITI to set up the Center of Excellence. There are some components which are already there, like Nismar put up the HyperWorks suite of software, the hardware, everything is already available. Now what we are trying to work on is the expertise that is required the domain expertise that is required to help the engineers from the local tier 2 and tier 3 suppliers to develop the products on their own, okay. So that's something that MITI would be pretty soon unveiling on the plan. So just to show you a snippet, this is what is available right now. You have the hardware already with all the software loaded, fully ready to be used. I guess that's what he was offering. So 1 month free trial. Anybody wants to use this facility, is welcome to use the facility. Use any kind of software from this staple, or free to use the software. Any kind of training we'll be providing along with our partners ORS. From a software perspective, and if you require any domain expertise to develop your own design, so we'll be helping you with that as well, okay. So that's what I had to sort of share with you from a perspective of our collaboration, and what is in it for you, on this collaboration. So I leave you with a video which I like so much. Possibly sometimes we'll sit down together to put together a program like this. So that's testing the boundaries of technology. What can be done, how we can push the boundaries harder. So I'm sure, you know, there might be some programs, that somebody might conceive and put together here in Malaysia. It might be quite exciting to work on such programs. This was a joint exercise by many companies and universities to essentially test the boundaries of technology. So I just leave you with this thought.